Why is magnification so important for metallography? Imagine trying to solve a mystery with only a glimpse of the clues. That's what examining metals without magnification is like. You're missing the details that tell the full story. When it comes to understanding why a metal part failed or broke down, seeing the tiny features inside the material is essential. Metallography is all about preparing a sample and then looking at it under a microscope to see its microstructure. But why is magnification such a key part of this process? Well, it all comes down to the tiny details that influence how metals behave and fail. Optical microscopes usually give magnifications from 10 times to 1,000 times. This range helps us see larger features like grain boundaries and phases, which are important for understanding the material's overall structure. But sometimes, these features are too small to see clearly. That's where scanning electron microscopes come in. They can magnify up to hundreds of thousands of times, revealing tiny cracks, voids, or inclusions that can cause failure. Without this level of detail, many critical clues would stay hidden. Magnification helps identify changes in the microstructure caused by manufacturing or heat treatment. These changes can weaken the material and lead to failure. It also allows us to spot surface and subsurface defects like cracks or corrosion pits that often start the failure process. When analyzing fracture surfaces, magnification shows us whether the break was brittle, ductile, or caused by fatigue. This information helps determine the failure mode. Another reason magnification is so important is that it shows us how phases or precipitates are distributed inside the metal. These tiny particles can greatly influence the strength and toughness of the material. It also helps evaluate the quality of welding, machining, or coatings by revealing any microstructural issues. Without enough magnification, these details stay hidden, and it becomes nearly impossible to figure out why a part failed. Higher magnification improves resolution and contrast, making subtle features like phase boundaries or microvoids easier to see. This clarity is vital for accurate failure analysis. Usually, Metallography start with optical microscopes to get an overview and then move to scanning electron microscopes for more detailed investigation. This step-by-step approach makes the process efficient and thorough. In the end, magnification opens the door to the microscopic world inside metals. It reveals the clues that explain how and why a material failed. By understanding these tiny features, engineers and metallographers can improve material design, processing, and prevent future breakdowns. Magnification truly is a fundamental tool in failure analysis, helping us see what the naked eye cannot.